Hello everyone. Today we study about the set theory. So, the set is a collection of the objects. This is the example of set, collection of the object. Any object belonging to the set is called a member of the set or elements of the set. So, this lower letter A, B, C, D are the member of the set and A is a set. Capital letters are used to denote the set and lower letters are used to denote the elements. If P belongs to the set A, then we write P belongs to A. This is the symbol to represent the elements of the set. And if we write not equal to, means this symbol denotes Q does not belong to A. Capital letters are used to denote the set and lower letters are used to denote the elements. This is the another way to represent the set. This set tells that X such that X is an odd number. So we write as it is, set is the collection of odd number. Now the next concept, inclusion and equality of the set. First, inclusion or the subset. For set A and B, if every element of A is an element of B, then A is called subset of B or B includes A. So this represents as A is a subset of B, means suppose A set is 1, 2 and B set is 1, 2, 3. Then all the elements of A are present in set B. So we tell as A is a subset of B. Now the equality. Two set A and B are said to be equal if A is a subset of B and B is a subset of A. Means A is equal to B. That time we said that A and B are the equal. There are three properties: reflexive, symmetric and transitive. Reflexive means A equal to A, symmetric means A equal to B, then B equal to A, and transitive means A equal to B and B equal to C, then A equal to C. Now next concept is proper subset. A set A is called a proper subset of B if A is a subset of B and A is not equal to B. Next concept is universal set. A set is a universal set if it includes every set under the discussion, denoted by that symbol. Empty set or null set. A set which does not contain any element is called the empty set, denoted by 5. Next is power set. A set of all subset of A is called the power of set, denoted by row of A or 2 raised to A. Empty set's power set is also empty. So power of empty subset is empty, means row of 5 is also 5 because empty set has no any single element. Next is S1 is the set of A, so the subset is, first every set has 5 is the subset. Then next another is A. So this is the subset of S1. Now the next set is S2. So as it is, first element is 5, second is single A, then single B, then pair of AB. So I hope you understand. The power set is a set of all subset. So how we find how many subsets are created by one set? if number of members are n, suppose number of member is n, then 2 raised to n subset are formed. This is the formula. So here 2 members are present, then 2 raised to 2 means 4. That's why here 4 subsets are formed. Suppose now here 3 members are present, then the number of subset is 2 raised to 3, means total 8 subset are formed by using this single set. How we find which set is formed? That's why one trick is here. How we write subset correctly? So here 2 members are present. Then first write, if 2, then write in binary 2 bits, means 0 0, 1 0, 0 1 and 1 1. And this first bit for first element and second bit for the second element. And when 1 is present, that time that element write, and if 0, then don't write the second element. So here both are the 0. So first subset is 5, means empty. Second 1 0 means first element write and second element doesn't write. So that's why we write 1. A. Now 0 1. 1 is second time, so write second element, which is B. And third subset is 1 ones, means both the element. Now our power set is ready, and we know the element is 2, then the number of subset is 2 raised to n, means 2 raised to 2 4. So 1 2 3 4. Now we confirm our subset is right. Now suppose the set is A B C D. So how many subset we create? 2 raised to 4, because 4 members are present. So total 16 subsets we form by using this single set. Suppose in this question, if in the exam we have question find out B 7th subset, means 7th subset from the power set, then how we find out? The same trick. First 7 in a binary form, which is B, and 4 elements are present, so 4 byte we take 0 1 1 1. And now we write this is first member, second member, third member and fourth member. So we want only last 3 members. So B 7th subset is B C D, because A has a 0 bit. Next set is intersection set. Intersection of any two set A and B, which is represented as A intersection B, is a set containing element belonging to both set. Suppose A is given 1 2 3 4 and B is a set of 5 2 3, then the intersection means which element has common in both elements 2 and 3. So A intersection B is 2 and 3. Now second is disjunction. Two set A and B are the disjunction if A intersection B is equal to 5, means empty. No single element is common. Always A intersection B is empty. Second is union set. For any two set A and B is union of A union B, it's a set of all elements which are member of A or B or both. In short, union means combine both set A and B and write A union B, means combination of both elements. Suppose these two element is given, then we want to write union A union B. That time combine the both elements, means 1 2 3 4 and 5 and 6. When we write all the elements of both the set, then this is called the union of two sets. Don't write 2 times and 3 2 times. If any element is repeat, that time only write at once. So A union B means 1, 2, 3, 4, 5, 6. This is the union set of A and B. Next is relative complement. Let A and B be any two set. The relative complement of B in A, written as A minus B, means A relative complement B, is the set containing those elements of A which are not element of B. Suppose these two elements is given A and B, then A minus B is the elements of A which is not present in B, means separate B's element from A and write remaining all the elements of A, means here 3 and 4 present in B also. So instead of 3 and 4, remaining all elements are the A minus B, 1, 2 and 5, and 3 and 4 we not write because this also present in B. So separate B's element from A and write remaining all elements as it is. Let universal set and set A is given, then E minus A is the absolute complement of A. This is denoted by this. Now the symmetric difference. Symmetric difference of two set A and B is denoted by A plus B, which is union of A minus B and B minus A. Now ordered pair. An ordered pair consists of two objects in a given fixed order. Ordering of the two objects is important, which is denoted as in between less than equal to symbol X and Y. Means in between less than equal to symbol write the members of the set. Now 2 and 1 is not equal to 1 and 2 because the definition is given here. The ordering pair consists of two objects in a fixed order. Means if suppose this is X and Y, then we not write Y and X. The order of the elements are the fixed. If 3 elements are given, then this is called the ordered triplet. If 4 elements are given, then this is called ordered quadrat. Now next concept is Cartesian product. Cartesian product of two set A and B is the set of all ordered pair such that first member is an element of A and second member is an element of B. Suppose now the question is given A is equal to set of alpha and beta and B is set of 1, 2, 3. What are the A into B? Means this is the symbol of Cartesian product. B into A into A. Now we see A into B means first element is always present from the A set and second element is present from the B set. So first we take alpha is the first element and one element from the beta, B set. So alpha and 1, alpha and 2, alpha and 3, beta and 1, beta and 2 and beta and 3. So condition is fulfilled here. One element, first element is from the A set and second element is the set B. So now B and A means we want first element from the set B and second element we want from the A. So first element of B is 1. So 1 and alpha, 1 and beta, 2 and alpha and 2 and beta, 3 and alpha and 3 and beta. In the same way AA. So we want both element from the A set and B into B means both the element from set B. I hope you all get the idea. If the question is given, write the Cartesian product of this set, then you write correctly. Now some properties are there. First is reflexive. Definition is present in the PDF which is in the description box. Now I only give the idea what is meant by the reflexive. Means if X relation with X example 1 1 2 2 3 3. If that type of set is given, then it is a reflexive. Now the symmetry. If x relation with y is equal to y relation with x, means in given set, if 1 2 is present, then 2 1 is also present. If that type of set is given, then the property is symmetric, means here 1 and 2 present, so 2 and 1 also present. 3 and 4 is present, then 4 and 3 is also present. So that type of matrix, that type of set is called the symmetric set. Now the transitive. Transitive means if x relation with y and y relation with z, then x is also relation with z. Means here in this set 1 and 2 and 2 and 4, the second element of first ordered set and first element of the second ordered set is common, same, then 1 and 4 is right here, means x and y and z, then write x and z. This is the transitive set. I hope you get the idea about the transitive also. Now next, irreflexive and antisymmetric. Irreflexive is opposite of the reflexive property, because in this reflexive we want 1 1 2 2, and irreflexive properties is opposite, means if 1 1 2 2 is present, that time it is not irreflexive. In irreflexive we doesn't want x x y y common element in ordered pair. We want different element 1 2 3 4, means no any common reflexive set is present in the set. And next is antisymmetric. In symmetric we have set like 1 2, then 2 and 1. This type of set is present, that time we say symmetric. And antisymmetric is opposite. We don't want symmetric set in the given set. We want different element 3 4 2 1 5 6. Don't want that like set. If that like set present, then it not a antisymmetric. This is a symmetric element and this is the antisymmetric. Suppose this is the given question, set S is 1 2 3 4 and the relation is 1 2 3 4 2 2 2 1 and 3 1. Now we find out the properties of the given set. So first is symmetric. Is it relation symmetric? What is the condition for the symmetric? We want if 1 2 is present, then 2 1 is also 1 2 present. So here in this example 1 2 present, so 2 1 is also present. So first elements satisfy the condition. Second 4 3, then we want 3 4 also. But in the given equation no present 3 4. So if one condition is not satisfied, then whole the property is false. So the given question is not follow the symmetric property. So no symmetric. Now we check reflexive. What we want reflexive? 1 1 2 2 3 3 4 4. That type element. But here only 2 2 is present, not 1 1 2 2 3 3 4 4. Both 4 elements are present. And for the condition of the reflexive, we want all the set of the given element in the form of XX. So the given equation is not also follow the reflexive property. Now transitive. For the condition of transitive, if 1 2 is present and 2 2 is present, then 1 and 2 also present. So yes, this condition is follow for the first set. Now 4 3 present, so 3 1 is any set start from 3? Yes, 3 and 1. So 4 and 1 we want in the given equation, but no 4 and 1 set is present. Now next also check 2 the second element of first is 2, then the any element which start from 2 s, and 2 and 1 is present here. 2 and 1, no, here 1 and 2 is present, so transitive properties also fail for the given question. If any one condition is false, then the whole property is not false for the given equation, so transitive properties also fail. Now irreflexive, this also fail because we doesn't want any single set of type XX. Here 2 is present, so this also fails. Now the next property is antisymmetric. Antisymmetric condition is want if x and y is present, then if x and y is present, then we doesn't want y and x, but here present 1 and 2 is present, then 2 and 1 is also present, so the antisymmetric property also fail for that particular given equation. Now one more concept of the set is draw the matrix. How we draw the matrix for the given set? Let's we see how to draw matrix. Let's we start. First 4 elements are given, then the matrix is 4 by 4. If 3 elements are given, then the matrix is formed by 3 by 3. So first write all the elements in row and column 1 2 3 4, and here also 1 2 3 4. This is the rough work. This I suggest this write using the pencil. Now the matrix we draw. So now in relation 1 and 2, first element for the row and second element for the column, so first and 2. So if the relation is formed, then write 1 for that, 1 and 2, and the set is denoted by 1. Now 4 and 3, the row is 4th and column is 3rd, so the set is also now we present by 1. Then 2 and 2, row is also 2 and column is also 2. Now 2 and 1, 2 and column is 1. 3 and 1, row is 3rd and column is 1. And the now remaining all the elements are the 0. So write 0 0 0. So our matrix is now ready. And one more concept is draw a graph for the given equation, given relation. That time what we do, first 4 elements are given, that's why we draw 4 nodes. 1 2 3 4. Draw the first elements of the node, then 1 and 2. Our node go from 1 to 2, so represent 1 to 2. Then 3 to 4, 3 to 4, 2 to 2. For represent 2 to 2, we draw a loop in this way, 2 to 2, 2 to 1, again go 2 to 1 and draw the 1 arrow, then 3 to 1, so 3 to 1 and draw arrow. I hope you get idea how to draw matrix and how to draw graph. One more trick I give how to find out the properties from the matrix. If all the diagonal elements are the 1, that time this is reflexive properties follow. If the given diagonal elements are the 0, that time irreflexive properties is follow. Because we know reflexive means 1 1, 2 2, 3 3, 4 4. So all the diagonal elements are 1, that time this is reflexive property follow, and at the irreflexive we don't want 1 1 2 2 3 3. That's why if all the diagonal elements are the 0, that time this follow irreflexive property. Now the symmetric. What we want symmetric? 1 2 is present, then that time 2 1 is also present. 1 2 is present, that time 2 and 1 also present. So in this way, if upper triangle and lower triangle are the equal, means 1 1 0 0 1 1, means 1 and 2 2 and 1, 3 and 1 1 and 3. That type of elements are the similar, that time this follows symmetric property. And opposite of that, antisymmetric, means if 2 and 1 is 1, then the opposite of 2 and 1 is 0. If that way matrices go, that time this is antisymmetric. Now one more example. A is equal to 1 2 3 4 and relation is given here. So we find out which property is follow for this example. First is reflexive. What is the condition for reflexive? We want 1 1 2 2 3 3 4 4, that type of elements of set. So here no present any 1 1 2 2 3 3 type of element set. So this not follow the reflexive property. Now symmetric property. What is the condition for the symmetric property? If 1 and 2 is present, then 2 and 1 is also want to present. But no, here any 2 and 1 set is present. Again we check 1 and 3. So we want 3 and 1 also. So no, the given question is not follow symmetric property also. So not symmetric properties follow. Now we check transitive property. Transitive property, we want if 1 and 2 is present, then starting of 2 and 4. So now what element we want? 1 and 4 is also present. So yes, here first element is satisfy the condition 1 and 2, 2 and 4, then 1 and 4 is also present, 1 and 4. Now second set we check 1 and 3, then starting of 3 is 3 and 4. Now we want 1 and 4. So yes, 1 and 4 is also present. Now we check third element 1 and 4, starting of 4 is present, no. So this set is fails the condition. For our better understanding, we repeat check this second set 2 and 3, starting of 3 is present, yes 3 is present. So we want 2 and 4. So 2 and 4 present, but one set of element is not follow the given condition. If single set is not follow, then the whole property fails. That's why the transitive property is not satisfy the given question. Now reflexive. The condition for the reflexive, no want any set of element is same x type. So yes, in this question no any 1 1 2 2 3 3 4 4 set is present. So this follow irreflexive property. And for the antisymmetric, we don't want 1 2 then 2 and 1 also. So no, here no any element follow the symmetric property. That's why this follow antisymmetric property. I hope you get idea about all those properties. Now we draw the matrix for the given relation. So as it is, first write all the elements at the row and the column, then write 1 and 2. We know first element is for the row and second for the column. So 1 and 2, 1 and 2, and write 1 to represent the set. Now 1 and 3, 1 and 3, 1. 1 and 4 for the first row and fourth column. Now 2 and 3, 2 and 3 as. In this way draw all the sets. Now as we know, if all the diagonal elements are the 0, that time it follow the irreflexive property. For the cross checking, if you want to cross check the answer, that time draw the matrix and check. All the diagonal elements are the one, that time it follow reflexive property, and if all the diagonal elements are the 0, that time it follow irreflexive property. Now here 2 and 1 is 0, and 1 and 2 is 1. So as it is, I said if upper triangular elements and lower triangular elements are the same, that time it follows symmetric property. And if upper triangular elements and the lower triangular elements are the opposite, 1 and 0, that time it follow antisymmetric properties. Now we sure about our answer. Now we draw the graph. First element is 1 and 2. First draw 4 nodes for the question. Then first element is go from 1 to 2. That's why draw the arrow as shown here. Then second element is 1, 3. We go from 1 to 3. Now third set is 1, 4 and 2, 3. 1 to 4, 2 to 3. And last two sets are 3, 4, 2, 4. 3, 4 and 2 to 4. So this is the graphical representation of the given set. Now I hope you all aware about. Now I hope you get the idea about the relations. Now we see the example which are neither reflexive nor irreflexive. So given set is 1, 2, 3, 4 and relations are 1, 1, 2, 2, 1, 2, 2, 3. So the given equation is irreflexive, neither reflexive nor irreflexive. Why? For the reflexive we want all the elements in the set of XX, but here only 1 and 2 is present, 3 and 4 is not present. And for the condition of irreflexive, we don't want a single set in the form of XX, but here 2 set are present. So the given set is neither reflexive nor irreflexive. Now the second, symmetric, neither symmetric nor antisymmetric. So the given set is 1, 2, 3, 4 and the relation is 1, 1, 1, 2, 2, 1 and 3, 4. So first, for the symmetric we want if 1, 2 is present, then 2, 1 is also present. Now 1, 1 present, the opposite 1, 1 means this also set follow the symmetric, this 2 also follow the symmetric, but third one 3, 4 is present, but 4, 3 is present, no. So this set is not follow the condition of the symmetric property. So this is neither symmetric. Now we check for the antisymmetric. The condition for the antisymmetric, we don't want any single element follow the property of symmetric property. So 1, 2 and 2, 1 both are the set follow the symmetric properties. So that's why the given example is neither symmetric nor antisymmetric. Now the next concept is partition and covering. So covering means if the given set is ABC and A is a relation which A, B, B, C, then if we do union of A, that time we get the first given set. And partition set means no single element we want common in the A. So the given set is a partition set. We want A is a mutually disjoint. That's why the given set is a partition set. Now the next concept is a equivalence relation. A relation is a equivalence if it is reflexive, symmetric and transitive. Example, equality of the member of a set of a real number means if A is 1, 2, 3, 4, then the relation 1, 1, 2, 2, 3, 3, 4, 4, 1, 2 means the given relation is follow symmetric, reflexive and transitive. Let's we check. For the reflexive, we want all the 4 elements in the form of XX. So 1, 2, 3, 4 is present, means this follow reflexive. Now we check for the symmetric. For the symmetric, we want if 1 4 is present, then the 4 1 is also present. So yes, present here. If 2 3 is present, then 3 2 is also want to present. So present. So all the elements follow the symmetric property also. Now we check for the transitive. What is the condition for the transitive? The second element of the first set and the first element of the second set, means 1 1 and starting of the 1 is present. Yes, here starting of 1 is also present. Then the 1 and 4 is want to present in the given set. So yes, 4 and 1 is present. Now we check for the second. 2 2 is present and the second element of 2, starting of 2 is present. Yes, starting of 2 is present. Then the 3 and 2 is also present. So all these 3 properties follow from the given equation. So the given example is a equivalence relation follow. Now second is a compatibility relation. A relation R is a set of X. It's said to be compatibility relation if it is a reflexive and symmetric. Obviously all the equivalence relations are the compatibility relation. Now next concept is composition of the binary relation, which is represented as R0S. Let R be the relation of X to Y and S be the relation of Y to Z. Then R dot, the small circle, is represent the relation of the composition of the set. Then XZ, such that X belong to capital X and Z belong to capital Z, where Y is a set elements of the Y and XY are the relations belongs to the relation and YZ is also belongs to the S. For example, the R set is 1 2 3 4 and 2 2 and S set is 4 2 2 5 3 1 and 1 3. Now we want to find out R dot S. So 1 2, then starting of 2 is present. Yes, in the S set starting of 2 is present. Then the set 1 5 is the R dot S. 3 4, if end of the first set and the second set starting is common, then another 2 elements are written in R dot S, means 3 4, then 4 2 is also present. Now 3 and 2 is the R dot S. Now check for the next element. 2 2 is present and 2 1 is present. Now 2 5 is the R dot S. One more example here. Here X is equal to 1 2 3 4 and F and G is given in the relations. Let R is the relation of X to Y and S is the relation of Y to Z. Then R dot S we know XZ. So in short, X and Y is the relation and Y and Z is the relation. Then R dot S is X relation with Z also. So let first set is 1 2. Then we want F dot G, means first element we give priority first and second priority for the G, and we check 1 2, then any element start from 2 S here. So what is F dot G? 1 and 4. Now F second set of F is 3 4. Any set start from 4? Yes. Then 3 and 2 is the F dot G. And 3, 2 and 2. Any element start from 2? S. Here 2 elements are the start from 2. So first we write 2 and 4, and for the second element 2 and 3. Now we check exactly opposite. First priority we give for G and second priority give for F, because we want to find out G dot S. So first we check 4 and 2. So any element start from 2 as here. So 4 and 2, 2 and 2. So the G dot F is 4 and 2. Now 2 and 4. Any element start from 4 in F? No. So no any effect on G dot F. Now 3 and 1. Any element start from 1? Yes, here 1 and 2. So next set is 3 and 2 because 1 is cut. 3 and 2. And next one is 2 and 3. Any element start from 3 as here. So the element is 2 and 4. I hope you get the idea about the composition of the binary relation. Now the next concept is poset, partial ordered set. A ordered pair P and the symbol of the poset is called a poset when P is a set of element and smaller than, means this is a set of representation of the poset is a partially ordered relation, is reflexive, symmetric and transitive on set P. Any graphical representation for the poset is called the hash diagram. So now we draw here hash diagram, means for the 2, 6, 24 starting of 2, then it connected 6 and 24 both because both are divides. Here mention draw the hash diagram following set under partial ordering relation divides and indicate which is totally ordered, means 2 divides 24 and 2 divides 6 both, and 6 also divides 26. So that's why here triangle is formed. Now in the same way 3, 5, 15. 3 is not divide 5 and 5 not divides 3, but both are the divides for the 15. That's why 15 goes from 3 and 5 both. One more example, let A be a set of the factors of a particular positive integer m and let poset be a relation. So x and y such that x belongs to A and y belongs to A and x divides y, means here m is given and we want to create set which is divides to both 12 and 25 and draw the hash diagram. So in this way we first find out all the divides which divide to the 12, 1, 2, 3, 4, 6 and 12. Now we draw hash diagram. So 1 go for 2 and 3, then both 2 and 3 divides to 6 and 2 divides 4 and 4 and 6 both divide 12 also and 3 also divides to 12. So in this way we draw the hash diagram. Now for the 45, 1, 3, 5, 9, 15 and 45 are the divides. Then 1 divides 3 and 5, then 15 divides 3 and 5, then 45 and 9, because the 9 and 15 both are the relation with 45. So in this way draw the hash diagram. Now next concept is converse of the relation. A given relation R from x to y, relation R bar from x to y to x is called the converse of R, is obtained by the interchanging the members of considered pair R. Means here R is given 1, 2, 3, 4. Now the converse of the relation is 2, 1, 4, 3. Interchange the positions of the member. This is the converse of the relation. Now here some terminologies are here. First is least member, second is greatest member, minimal member, maximal member, upper bond, lower bond, least upper bond, greatest lower bond. So least member and greatest members are the unique, means if the given hash diagram is that like, then the least member is 1 and greatest member is 4. But If hash diagram is that like, then it is not a unique, because here two members are present in the lower side and two members are present in the upper side. So it is not a least member or greatest member present in the given hash diagram. Now the minimal member and maximal member. Minimal member means lower level elements and the maximum members means upper level members. Now upper bond and lower bond. Least upper member bond and greatest lower bond. These four terminologies we understand with the help of the example. Suppose for the given example, subset is given 3 and 2. The upper bond is 3 and 4 and lower bond is 2 and 1. Starting from 3, starting from 2. Then least upper bond. From the upper bond we want least member, which is 3. For that, least upper bond is now 3 and greatest lower bond means from the lower bond we want greatest member, which is 2. We see one more example. For this example, no exist any lower and upper members, because we know the least member and upper member are the unique. Here no unique least member and upper member. Now the minimal member is 2 and 3, because the lower side 2 and 3 is present, and maximum member are the 24 and 26, because at upper side 24 and 36 are present. Now the set 2, 3, 6 is given. For that, upper bond is start from 6, 12, 36 and 24, and the lower bond is not exist. Now lower bond, least upper bond is 6, because in the upper bond least element is 6 and lower bond is not exist. That's why greatest lower bond is also not exist. I hope you get the idea about all this concept. Now in set 3, one more concept is remaining, which is function. We see the function concept in the next video. Thank you.